I want us to talk about our rectangular coordinate system. I've drawn the x-axis, which is just like the normal number line. You have 0 in the middle, positive numbers 1, 2, 3, 4, 5, 6, so forth on to the right. Negative numbers, -1, -2, -3, -4, -5, and so forth on to the left. This is your y-axis. The vertical line is your y-axis. And you have positive numbers going upward, 0 in the middle, and negative numbers going downward. We have quadrants. We've been working so far in quadrant 1 on our previous examples. In quadrant 1, if you have a point, say right here, your x is positive and your y is positive. So the name of this point would be out 4 on the x-axis, up 2 on the y-axis. So the name of that point would be 4, 2. This is all quadrant 1. Quadrants go counterclockwise. This is quadrant 2. Notice I'm using Roman numerals. Here's 1, 2. Let's name this point. The name of this point would be, go the x road first, go out on the x to -4. And you go up 2 on the y. So the name of this point's -4, 2. To be in quadrant 2, the x is negative and the y is positive. To be in quadrant 1, they're both positive. Going counterclockwise, this is quadrant 3 down in this area. Notice I named it with the Roman numerals 3. Let's look at this point right here. The name of this point would be to the left -3, so x is -3, and down 1, 2, 3. So -3, -3 would be the name of this point. We go to be in quadrant 3, they're both negative. Both the x and the y are negative. To be in quadrant 4, I'm going to make us a point here. We go out on the x +3, and we come down at -3. So to be in quadrant 4, the x is positive, the y is negative. Notice how we write a 4 in Roman numerals, the I and a V. Let's talk about this point right here. The name of this point, that's a point on the x-axis. That's the point 4, 0. Of course, we know that origin is 0, 0. The name of this point right here, we didn't go anywhere on the x, so the x is 0, and we came down 4 on the y, so that's 0, -4. So I just wanted to go through and talk a little bit about our points on the rectangular coordinate system. So next, I want us to begin looking at this problem here. It's a problem from Part 3, Section 5.1, graphing proportional relationships in Quadrant 4. Ice forms at 0 degrees Celsius. The surface temperature of the ice on an ice rink decreases 0.5 degrees Celsius every hour. Draw a graph to model this situation. Start when the surface temperature of the ice is 0 degrees Celsius. And the question is the surface temperature of the ice proportional to time? How do you know? Well, the first thing we would want to do is create a table of time in hours compared to temperature in degrees Celsius. So, of course, at 0 time, we have 0 degrees. We are to start when the surface temperature of the ice is 0 degrees Celsius. All right, so in 1 hour, it said the surface temperature of ice in the ice rink decreases 0.5 degrees Celsius every hour. Decreases, that's going below 0, so that would be negative 0.5. So it's decreasing 0.5 degrees Celsius every hour. So after 1 hour, it would be at negative 0.5. After 2 hours, we're decreasing another negative 0.5. So you could add negative 0.5 plus negative 0.5, negative 0.5 plus negative 0.5. On your calculator, you get negative 1. At 3, you decrease another 0.5. So that would be negative 1 plus negative 0.5 would give you negative 1.5. Okay? And then the 4th hour, you're decreasing 0.5 every time, so negative 1.5 plus negative 0.5 again on your calculator should give you negative 2. So you're decreasing 0.5 every hour. Okay, so the temperature decreases by 0.5 degrees Celsius every hour, starting from 0 degrees Celsius at time 0. All right, so now let's talk about drawing our graph. Which quadrant are we in? If our x values are 0 and our y values are negative, I believe we're going to be in the 4th quadrant. So here I'll have my x values here. These will represent time. So I would be at, of course, 0 here, 1, 2, 3, 4, 5, 5, 6, and so forth on. Then we'll have our negatives coming down to represent the temperature. This is the ice surface. Temperature. So the temperature is every 0.5. We're decreasing 0.5 each hour. So I'm just going to use negatives, negative 1, negative 2, negative 3, negative 4, and so forth on. Okay? So at 0, 0, that's our first point. 0, 0. I made a point here. Then we have the point 1, negative 0.5. So 1, negative 0.5 would be to the right 1, and halfway down would be, halfway in between 0 and negative 1 would be negative 0.5. Then we have the point 2, negative 1. So to the right 2, down negative 1 right there. We have the point 3, negative 1.5. So to the right 3, down 1.5. Then we have 4, negative 2. These were points we found earlier. To the right 4, down negative 2. So you see my line is coming downward. So the graph of the line does pass through the origin. It does show proportional relationship between time and the temperature of the ice. The graph of the line that passes through the origin, it shows each hour that passes, the ice gets 0.5 degrees colder. So I want us to look at another graph that was drawn and used. Here it is. You see every little marking across the x-axis was representing 1, although they left 1 and 3 off. Here, every little marking you see was representing 0.5, negative, 0.5, 1, 1.5, 2, 2.5. These are all negatives because it was decreasing at 0.5 degrees Celsius every hour. So even though graphs may be a little different, you can see these still represent the same thing. I still see my point 0, 0. I still see the point 1, negative 0.5. I still see the point 2, negative 1. I still see the point 3, to the right 3, down 1.5. And I still see the point 4, negative 2.